I first, well, the way that I encountered James was I read a paper that he was a co-author on. That was a study of pollinator abundance and diversity in two different utility scale solar installations in Minnesota. And I was super interested in that, and I started going through the list of authors on there, looking for somebody who would be able to speak to us about kind of the engineering constraints that are involved in solar projects, as well as some of the economic reasoning that goes into how solar installations are vegetated or not. And with a particular interest in kind of dual use solar and agrivoltaics. And I think I started looking into James's background and interests, and it seemed like he checked all the boxes. So, James, we really welcome you to the Native Seed Stakeholder Meeting, and wondered if things are you getting things set up on your end okay?
Perfect. Then I can go ahead and just get started. Thank you for the introduction, Lauren. I'm going to go over some of the research projects that we have going on kind of throughout the United States, try to kind of focus a bit on pollinator habitat, and then I can try to kind of steer some of my remarks towards kind of more of the engineering constraints and kind of like what we're hearing from kind of the industry on some of the cost side. So really kind of I wanted to kind of set the framework for why, we're actually doing this work at NREL, and basically the graph on the right is showing kind of a solar development build out, basically from now until 2050, based on some kind of cost projections of both solar, wind, and other kind of generation sources. But that's going to result in a pretty massive kind of transformation of land throughout the United States, mainly in the kind of the arid Southwest, the Midwest, and then the Southeast. But that's kind of comes with a lot of kind of issues associated with that. And so what we are seeing in kind of response to this is a bunch of policies being kind of proposed for either pollinator guidelines or basically agrivoltaics kind of incentives on kind of how can we do dual use solar at facilities kind of across the US. And so that's kind of at least the background, kind of what we're seeing and kind of what is driving a lot of this research and energy around this, both from the kind of the pollinator habitat perspective, but also from kind of the other kind of cropping perspective, which kind of leads into one of actually probably my more controversial slides that I have, which is like what is actually the definition of agrivoltaics? Because depending on the entity that you talk to, they're going to kind of push their kind of what their group is actually good for. So at NREL, we kind of take more of a broad tent kind of perspective to the term agrivoltaics, which is kind of basically some type of crop production integration, some grazing, pollinator habitat and apiaries, and then kind of also controlled environment agriculture with solar. So I'll focus most of my remarks on this pollinator habitat and apiaries and grazing, but just wanted to highlight that we're kind of looking at the broad spectrum of kind of different solutions for dual land use solar. And so this leads into kind of one of our main kind of research projects, which is the Inspire project, or innovative solar practices integrated with rural economies and ecosystems. And it's basically kind of this is our now just started our ninth year of research, and then have kind of three more planned with the U.S. Department of Energy, the Solar Energy Technology Office being our main funder. We're basically looking at both kind of field research on kind of can we do kind of these novel agrivoltaics and pollinator habitat designs associated with, basically agricultural yields, irrigation requirements, some grazing standards, and then also kind of ecological services at these sites. But then coupling that with what I think kind of some of my work kind of tends to focus on, which is the cost benefit trade-offs of different agrivoltaics configurations, why decisions are kind of made at different sites, and then kind of taking a look at kind of these projects throughout the United States. So we're currently working at 24 different sites just on the Inspire project throughout the country. And that's basically kind of has a fairly wide geographic range. And most of these sites, I would say, are some sort of pollinator habitat coupled with grazing kind of production. But we do have a few sites that we're coordinating that are kind of much more about crop production. So just showing that there's even just across this spectrum of agrivoltaics, there's a lot of different kind of setups and designs that people are basically studying. And so I think that this kind of shows pretty well kind of the what the current state of agrivoltaics in the United States is. The on this map that you can see, a lot of the bees are basically pollinator habitat that's been established with solar sites, and then the sheep are basically kind of grazing operations that are currently going on. It's predominantly, if not 100% sheep currently. There are a couple of sites that are testing out cattle, both in western Minnesota and then a new site in kind of South Georgia. But basically showing that a lot of the solar industry has at least currently incorporated both pollinator habitat into their operations based on some of the cost implications and also kind of local policies or grazing, which both is as cheap or cheaper than mowing and kind of comes with kind of an added side benefit that we'll go into a bit. And so that is kind of the pollinator habitat. And again, this is kind of the debate that's kind of going on amongst different entities. Is basically pollinator habitat. Is that agrivoltaics? And so some people have termed this term ecovoltaics, or kind of these ecosystem services benefits of pollinator habitat. And so what we're seeing is that the at least the first 3 or 4 years of research was really looking at, can we actually establish pollinator habitat at these solar sites? Short answer is yes, given the right conditions. And then we're basically evaluating kind of persistence of these different seed mixes at different sites to see, okay, so what establishes in the first 2 or 3 years, and then what actually persists over time, and do these sites eventually establish well enough to kind of outcompete weeds. And so some of the cost and design factors that we're seeing is really driven by the install cost up front. So a lot of these sites are basically the lowest edge of the panels when it's tilted, which is a predominant of the utility scale solar sites. A lot of these sites are being designed for about an 18-inch kind of ground clearance. It's 18, 24, 36. We've seen higher depending on the kind of the region and some of the snow loading. But I think for anyone who is a native seed or kind of involved in native seed growth, there are not a lot of native plants that are going to grow to an 18-inch height, and there's a lot of insurance requirements from these companies that we cannot have any vegetation over 18 inches or over that lowest edge of the panel. Otherwise, they will actually lose insurance and then could potentially lose the ability to sell power to the grid. So we're seeing this kind of trade-off of, do we spend a little more upfront to kind of raise the panels to then allow kind of much more kind of seed selection, or do we kind of just basically try to design around what the current PV design is, which generally is going to be a turf grass and kind of like some type of, or fescue and some type of white Dutch clover mix, which has been fairly prominent throughout the Midwest. And so that's the continual battle between both the upfront cost and then the people who operate and maintain the site, which are often not the same entity, or the site is sold, and there's a lot of decisions that kind of go into that. And so that's kind of the really, we needed to kind of figure out what are these actual trade-offs, and so I'll go over a little bit of that. But what we're seeing is at another kind of project that's looking at kind of the what are the implications for the large scale solar sites that have these kind of impacts. And so most of the sites that we're working at are 10 to 20 acres, but a lot of solar sites that we're seeing are, can be tens of thousands of acres, or even, more than that. And so we're seeing this kind of at least what we're seeing at large scale solar sites is that there's a difference between what is being planted in the exterior or kind of like non-under panel area, and then basically underneath the panels, basically to comply with the insurance kind of requirements. And so we're trying to assess, or at least kind of come up with like a framework to assess, like, even if we have high value kind of native kind of pollinator in the buffer area, but then some type of fescue clover mix underneath the panels to kind of save cost and also to allow for for the ability to have insurance, we're trying to see kind of, does this still give ecological value? Very similar to, I think a project that's probably going to be very familiar to people in Iowa, the kind of the Prairie Strip project. If you, out of Iowa State University, if you establish small kind of, pockets of high value pollinator habitat, is that still going to be beneficial versus just trying to kind of do the entire site native, which is going to come at a lot of cost and also operations concerns. So that's some of the things that we're trying to look at and kind of work with industry on. But I wanted to highlight some ongoing research that we have that I think, Lauren referred to this. Basically, the paper that was published by Argonne National Laboratory is looking at kind of basically establishing pollinator habitat at 3 Midwest solar sites, and kind of like taking a look at kind of different seed mixes throughout those solar sites to see actually what establishes, what persists. But then we're also looking at the impact of pollinator habitat on PV performance, the impact of kind of a partial shade environment on different seed mixes and different kind of species, and then kind of some characterization of broader benefits of pollinator habitat, such as stormwater runoff decreases, carbon sequestration, and kind of more general kind of soil health kind of metrics. And so really the what we ended up doing was we tested 8 different seed mixes, roughly 105 different species planted in kind of different test areas, and then also looked at like different areas with multiple planting approaches and management planting styles and management approaches. So it's, we mowed one area, we didn't mow one area. We planted the same seed mix at different times throughout the year. And basically trying to kind of inform the what should you plant eventually at these kind of solar sites. And just as kind of like a reference that, this is the same seed mix at 3 different sites within about an hour drive of each other in different kind of climatic regions, different soil kind of considerations at the exact same time. And so highlighting that even at these sites, we're seeing a different establishment rate and different kind of like different regime within that. And so that's kind of been kind of one of the interesting findings. And so what we really wanted to do was basically say, if you plant native pollinator habitat at solar sites, will the prairie establish underneath the panels? And so what we are seeing is that over time, the answer is yes, with basically no management, at least currently. We have started managing these plots a little more actively to see kind of if that has an impact. But basically that this does establish over time, not nearly as much as the kind of the full sun control, but still within kind of an acceptable limit outside of one site that had some kind of issues with actually flooding at that site. So there was some impacts on kind of some of our results, but showing that over time the native plants or the native seed bank actually comes back. And that was kind of a big finding. And then just like basically taking a look at just different kind of seed mixes and kind of how they establish at different areas. So even kind of amongst the same kind of like seed mixes do these plants establish. And for the most part, we're not seeing a ton of difference across different commercial kind of seed mixes. And then so that was the first 3 years of research. And our next 3 years of research, we're looking at, okay, so this established, what is actually going to persist over time? And so that's kind of going to be the subject of some more research in the next years. And I think in particular, there were certain things that we planted that we haven't, this was established in 2018, and we just started seeing some of the seed mixes pop up in 2023. And so again, that this is highlighted like long-term research is needed to see if these kind of microclimate changes actually have the impact. And then, so that's coupled with the plant side, and then going to the pollinator side, which is the Argonne paper that was actually referenced, was basically looking at if we have pollinator habitat there, do native pollinators actually show up on these sites, or native and other pollinators show up on these sites, highlighting kind of floral abundance increasing over time, which is then shown with an increase in both pollinator abundance and diversity over time, both on those sites, and then also kind of comparing to kind of some offsite controls. But just showing that this abundance does kind of increase over time, which makes sense, but we needed to kind of actually have some information around that. So that's kind of more of the field research side in Minnesota. But we're also doing some kind of look at operations and maintenance costs over time. So one of the theories is that if you establish native habitat, in theory, you should have to mow less over time. And so we're still waiting to kind of see on that, but we wanted to establish these kind of cost metrics around this of what are the actual costs of maintaining this vegetation for different practices over time. And so we have a paper that looked at kind of this initial survey of fairly young pollinator habitat sites, both for the mowing, the grazing, all this other kind of like impact. And kind of the main finding of that was that at the end of the day, sheep grazing, turf grass, and native vegetation had fairly similar operations and maintenance costs over time, but there was a lot wider range of operations and maintenance costs for native vegetation sites just based on the fact that you need to be a little more active in the first 2 or 3 years to actually establish this and so on and so forth. So we're still trying to kind of make the case from the cost perspective, kind of coupling this with some potential yield increases. Solar panels kind of like it colder. And so if the kind of evapotranspiration or the plants can actually keep the under panels actually cooler. We have seen some kind of generation increases in Southwest Arizona or in the Southwest in Arizona. But we're trying to say, does that actually work for the rest of the United States? And it turns out the answer varies depending on your situation. So I think we can say with a little certainty that in the Southwest, you're going to see a yield increase. In the Midwest, there's not. The evidence is a little scattered, and so we're still trying to kind of make sense of that based on the different climactic conditions there. Also wanted to highlight some work done actually by the University of Minnesota and Great Plains Institute that kind of NREL was more of the kind of the research manager on, was kind of looking at the stormwater runoff impacts of different sites throughout the country, and basically taking a look at what are the key drivers of stormwater runoff at solar sites, because a lot of these sites are being regulated from a stormwater perspective similar to parking lots. And we know that it's probably not kind of like a parking lot just because there's going to be some chance for infiltration because there's gaps in the panels. And also there's going to be some kind of space in between the panels that allows some stormwater to actually infiltrate. But it's also not going to be the identical to kind of a wide open prairie because there's going to be this other kind of like area in here. And so what the project ended up finding was that the largest determinants of runoff was basically the space in between the panels. So the larger the space, the more chance for infiltration. The type of ground cover established. So basically with native having more solar water runoff, fescue and other kind of setups having less, and then kind of the post-construction compaction of the soil. So those were the three predominant kind of drivers of runoff, and really not anything having to do with kind of the panel design for the most part. It did have an impact, but nowhere near as much as those kind of top three. So that was kind of an interesting finding, showing that it was trying to kind of put some science behind kind of how should you establish regulations around stormwater runoff at solar, because it's been kind of a big issue in parts of the country, predominantly in Virginia and the Northeast areas, where we're seeing some kind of stormwater runoff issues at these sites, mainly driven by deforestation and some other kind of impacts. And then just wanted to touch real quick on kind of some grazing, and kind of the kind of what we're seeing at these sites. As I mentioned, it's predominantly sheep in the United States, just based on the fact that they're docile. They're not going to rip up the panels, kind of like cattle or some other type of like larger ruminant. But basically showing that we're actually seeing impact over time in sites that have been grazed. So this is kind of can be compatible with our native pollinator habitat projects. But we're actually seeing both carbon and nitrogen increases over time at these sites for having sheep grazing on site. And so showing that, these are not going to be mutually exclusive over time. Am I doing on time? Okay, 20 minutes. And so yeah, and then so like, this is all kind of going into some other research that is looking at kind of what are the actual impacts on large scale. Like if you have to do this over so many kind of acres, what actually makes sense. And so this is kind of the phase project run by the University of Illinois, Chicago. And these highlight some of these challenges of kind of pollinator habitat, higher installation costs. The seeding cost is going to be pretty low compared to the actual installation cost. But as you can see, even right here on these panels that are really low to the ground, there's not a lot of native seed or even kind of commercial seed that can kind of stay with under that range. And so it really limits what you can do underneath the panels to a certain extent. And as I said, shading is just a huge concern because these projects are making money off of selling power. And if you shade part of the panel, it's going to reduce the power production. We're hearing some kind of the impact of kind of the timing of costs in that as I mentioned before, the people who build these projects are often not the people who operate it, or it's not the same group within that. And so increased upfront costs can actually lead, or decreased upfront costs can actually lead to higher life cycle project costs, because in the first, I think, 5 years, the largest operations and maintenance cost by far is vegetation management. And so again, it's these trade-offs and trying to kind of communicate these to kind of different parties on that front. We're hearing some commercial availability of seed mixes, or if we were to scale up all these policies to the national level, there could be potential impacts on kind of availability, but I don't think that I haven't heard that we're close to that yet, but it is kind of a concern going forward. And then there's also kind of the permitting aspect of, particularly for stormwater runoff, you need to get a certain ground cover in the first 2 or 3 years. But as we showed earlier, it takes a while for these native seed mixes to actually establish. And so there's actually a disconnect even there in terms of, well, this is what we want, but we're not allowing you to actually kind of meet your stormwater permit requirement from that front. So this project is really just trying to highlight, like, here's all these impacts, here's all the trade-offs, here's all the issues associated with this. And so I just wanted to highlight that out of this project, there should be some availability or these tools should be available fairly soon in terms of like implementing pollinator vegetation at solar sites, mainly aimed at developers. But basically trying to kind of inform the process up front, trying to kind of provide some education on why this matters, what are the issues, who you should be talking to, when, why, and so on and so forth. We're also kind of coming up with a cost comparison calculator, so kind of based on different seed and seed mix selections, there's the ability to kind of like look at the life cycle cost of that, and then some documentation around assessing habitat at these sites, and then also kind of different seed mixes. I think that's pretty much all the prepared material that I had. Apologies if I kind of went a little fast and kind of covered a lot of different kind of steps, but so I wanted to highlight that one of our main reports that's on our kind of like main website is basically looking at the basically 6 years of lessons learned from research, and kind of, basically these pieces: climate, the configuration of the PV panels, what you're trying to grow and cultivate, the compatibility with normal farming or other practices, and then collaboration of all these different entities is really these drivers of that. And so like a lot of lessons learned are basically located within this report. Just like wanted to highlight that as kind of one of these things, and we hope to be coming out with more pieces like this. So that's all I had. Our kind of website is here. I already shared my slides. This should be available to folks. And I'd be happy to answer any questions both now or over email. So I'll turn it back to the room for now.
So much, James. Let's go ahead and offer a run. And I'm going to do a little bit weird because I'm sort of a disembodied voice here, but I need to get the questions so that James can hear them. I need you to repeat them, or if you want to get your butt here, actually ask the question yourself, read the microphone, that would look pretty shit. Yeah, we're being sheet, you're taking the science center to talk about this about with the government. But research is I have it's a lot of questions that I am thinking about are English. Because
with a big hurdle is the seed availability, specifically seed that's going to fall within that under 18-inch. And as soon as you're something shorter than 18-inch, it becomes very difficult to harvest or optic, which makes it very expensive. How, from our standpoint, I mean, there's a group of us in the room, and then only a handful of more people in the Midwest that grow these seeds at some sort of scale. What does it? I don't know what. So I'm going to skip to. Are they looking at making requirements and code for native habitat having to be under those things? Because while it sounds great, it could pose huge problems about.
Yeah. I have not heard of mandates being proposed. I have heard of most of the guidelines that exist are just that, guidelines, and it's more, I think, kind of what we've been hearing. It's more about how kind of solar developers can kind of communicate it to the community versus like a mandate actually coming from like those local jurisdictions. I think your comments are spot on to kind of like what we're hearing from people in terms of like, yeah, if we mandate native vegetation that's under 18 inches, we're going to run into seed mix concerns over time, harvesting issues, and so on and so forth. So I have not heard of that mandate kind of coming forth, at least on the pollinator habitat side. And I think we're seeing some developers kind of almost self-select along those like lines in terms of some are basically making it part of their operating procedures. That's like what we're going to do. Others are going to do it only when they were forced to by like the local jurisdiction or, kind of during the community discovery process. And some are kind of in the middle. And so I think that I've not heard about a mandate, but I think it would cause some issues. Does that answer your question?
Yeah. And then what are the chances if there are only guidelines that people kind of follow those, and then within building solar complexes, what percentage is the price? Because if native seeds are how expensive is 0.02% of price, then who cares?
Yeah, that's, I think, something that we're trying to assess. We're actually looking at kind of the capital cost kind of piece up front. I don't have a good number of that. I think that's something that we're trying to get at, because I think that we don't really even have like a good assessment of like, outside of like a very traditional solar project, we don't really have a sense on like what the cost drivers are. Well, we don't have a sense of the magnitude of those cost drivers, I guess is probably the more accurate statement. And so we're trying to actually answer that question. Yeah. Seed is 2% of the upfront costs. We're still trying to kind of figure that out. But that is definitely something that is of interest. If anyone would like to kind of participate in some of those discussions, because I think we're having a hard time tracking down even just like install costs, per acre, and then kind of comparing that with solar. But I do think it'll be a small portion, but it could be larger depending on the aspect.
So I think for the NWTC trial, we had like a mountain height of here, and then it's one of the around plots at 2 meters. And I'm wondering, if we can have like 2 meter, 2.5 meter mounting height, then it's going to really open up the number of different plants to mixes that can be used. Is it with the NWTC trial that I think it mentioned that the primary reason for low mounting height was intense wind in the valley? And so, given the weather conditions in the Midwest, are there barriers other than cost that prevent like a cheat or mounting planning?
Yeah. So cost is the big one. For basically, at least for the driven post model, which most people are doing, for every foot above ground, you have to have at least 1 foot in the ground just for wind loading. And I think kind of once you go above about 2 meters, that's roughly the cutoff point, depending on the area, then you actually have to upsize the support size. And so it's not like a linear kind of like change. There's actually like a fairly massive impact on like the amount of steel needed once you go above about I think it's about 2 meters, depending on the area. Um, and that just like basically I think on a smaller project it's okay, but like when you're on, thousands of acres and you have 10-20,000 supports, that adds up pretty quick in terms of like that kind of increased cost. And so yeah, so it's wind loading and cost are the big two drivers that we're seeing for that. And yeah, I think the only reason that we're seeing kind of higher panels, and particularly in like the northern parts of the country, is mostly about, I think it's the sun angles in the winter, basically trying to kind of avoid shading, and then also kind of snow loading. Because if it's like lower to the ground, you're seeing a lot of snow drift on the top of that, and that's kind of been the impact. So there are parts of the country where they're already installing at like height. Thinking mainly in Minnesota, Wisconsin, Michigan, kind of those like northern latitude sites. But in the South, in particular, they just want as low to the ground as possible and to kind of reduce the cost as much as possible.
Thank you.
Yeah. Any other question, or people need coffee? Is that am I standing in the way of a break?
The place that is making sure that we call that a bit darker than that. Now, any other questions? I've been curious about early like soil conditions under the panel. There are species that are shorter growing that are more sedimentary, drier soils around here. And you have pretty easy conditions in this part of the country. And if you could manipulate the soil conditions from some of the minerals to diversify some of those shorter species, I wonder if we have a better exact even zero range that metals let's do issues. But I don't know what you think about that.
I think that makes sense, and that we are. I think what was the largest driver of some of our results in Minnesota was the one site was extremely sandy, dry soil, and that I think had kind of a larger impact than kind of pretty much most of anything else. I think it's interesting because we are seeing a shift, at least towards like as little ground disturbance as possible during an installation. And I think people are seeing that a benefit both from the upfront install cost and kind of like the long-term management cost. And I think what you're going to, at least what we have seen so far, is that the least impacts generally the better outcomes that people are having. And so I'd be curious, like, how that would work in terms of that. Like, if that would be like more of like a site selection kind of guideline, or specifically something that like the developer would do. But we are seeing really a big trend, because I think before they would just come in, they would just like remove the topsoil, they would grade everything, and then they would basically put the topsoil, or they would install the panels and put the topsoil back. And I think we're seeing a bit of fairly large shift away from that, at least in certain parts of the country, just based on kind of past outcomes with both establishing kind of ground cover and also just kind of cost. So yeah, I don't know how that would kind of interact with that kind of mechanism, at least that we're seeing currently.
Richie speaking. We have a couple of questions. Great. So there's been some reluctance or pushback in Iowa to covering large amounts of good full crop and the solar rates. And I'm wondering whether the establishment of the pollinator habitat or agrivoltaics is helping to sell solar. Is this a significant factor anywhere in of course meeting and pot in terms of acceptance of the kind of mass transformation of home use?
Yeah, I don't think that I have a good assessment of that. I think for the most part, it's going to be so dependent on the community and the project that I don't know if I have a generalizable answer about that. I think in some areas we are seeing that, and then in others, I think not. I think, particularly when it comes to like prime ag land and like transformation of ag to solar, I don't think that the pollinator habitat argument carries as much weight, but that also changes by kind of area. I think Minnesota, it's really just about trying to kind of reestablish prairie. And particularly like most of the sites that we're at, I think were previous corn and soy rotation fields. And so it's kind of about kind of returning that back to that. So yeah, I don't think that I have a good answer on that. I think it's going to vary a ton by area, region. And it's kind of interesting. We are seeing kind of like no one, or in some communities, like no one really bats an eye about the first project or the second project. It's like the third and the fourth project that people kind of start paying attention to. And so even I think the timing in the community on when that occurs is kind of playing an impact on that. So yeah, I don't think I have a good answer. I know that there's a lot of social scientists like looking at this, but I'm not as familiar with that kind of side of the research.
This question is going back a bit to Nicholas. Yeah. And Laura's. So you've got plants that maybe their potential as a species is a certain height, but the seed producer likes that height. It's easier to harvest. The solar sites want lower, so it's not shading the panels. What's happening in the research world about ways to manipulate conditions to kind of stress plants and make them shorter in that way?
I would actually ask that question to you because you're probably going to know better than I do. I'm kind of more on the engineering and kind of cost side than the actual biology side. I think it is something that is of interest, but I'm not currently aware of anything along those fronts, at least from my knowledge. I'm sure someone's looking at it.
Is that an opportunity for your being of the research community? I mean, or is that kind of like advanced level and we need to solve some of these other bottlenecks?
No, I think that I think like what we are going to see, and like this is, I think, going to be on the crop side. I think that there is going to be an opportunity. And so I think it's going to also apply to the pollinator side of like, if you can show, this is, been tested in kind of like shade environments in this region to only grow to this height, I think that would be of value to kind of establish that and have kind of like a neutral kind of entity take a look at that. And so I think kind of more of that, I guess, more seed selection, I guess, the side. I think it would be of value and it would be of interest. I just don't know how much. I can't like really assess that. But it's definitely an interesting concept.
Thank you.
Yeah.
Go back to the box listed lot. Explain that cost. Explain that. But
oh yeah. Let me find that. Sorry. Basically, what that was looking at was just basically a survey of different trying to multitask. There's a survey of different O&M providers for basically cost at this site. And so it's basically we tried to establish, kind of like what type of ground cover was there, either native vegetation, some type of turf, fescue and clover mix and gravel, and then also sites managed with kind of sheep grazing. But basically took a look at the different costs per year and kind of like events. So basically like how much the mowing costs at these turfgrass sites were across the sites that we looked at. And as you can see at the bottom, there's a lot of issues with the amount of sites that we had, kind of the actual data availability I think getting cost is just always difficult, just for many reasons. But basically, this is just trying to highlight that, kind of the range of costs of different activities, of different practices, mowing, weeding, or herbicide application over time, some type of tree trimming, and then these are kind of much more about kind of grazing kind of opportunities, but it's trying to kind of establish ranges of costs for this. And so I don't actually, in the paper, we actually have the kind of like the total cost by that. And so what we ended up finding was that you're doing less activities generally at different of these sites, but you're doing them more often. And so the kind of the costs kind of even out over time. And what we're just mostly seeing is that there's just a pretty wide variation of kind of different costs within these areas. Does that answer your question, or was there something else that you were curious about?
I was curious about the numbers down there. Those are locations and the number.
Yeah, this is the number of sites. Yep, exactly. Yeah. So again, like I don't think, and like I would say that like any of like at least the cost analyses that we do, like we don't really have. It's kind of we're kind of in an interesting position in that we can only really use what we can get. And so we probably know that these numbers are wrong, but it's also kind of like we're trying to establish the ranges around that. And it's funny, I feel like when you go and ask someone for kind of like what they think about, what the cost for each of these activities are, they won't give you a number. You publish the number, and then all of a sudden you get 8 people telling you that you're wrong and actually get you to update the cost. So that's kind of more kind of like what a lot of this was. But this is the only thing to our knowledge of at least kind of an assessment of cost, or at least some of the kind of the ranges and the order of magnitude of that. Fully recognizing that it's wrong, probably out of date, and kind of highly dependent on the sites that you get. So just a little caveat there.
Yeah, I think that those of us who are involved in research in prairie establishment and this part of the country and monitoring of that, understand the issues that you're talking about. You have your data as for example, you prevail to that.
Yeah.
But any other questions? I think that I can put things here. I really appreciate you taking your time to be with us today. And for responding to my email, back a couple weeks ago. And yeah, that's thank you and stuff again for joining us.
Yeah. Yeah, thank you so much for having me. As I said, we have a lot more information available on our website, and I'd be happy to hear, kind of thoughts or anything. I think my email should be at the end of those slides. So I would look forward to continuing the conversation if there's of interest. And yeah, thanks for your time.
Thank you so much, and have a great rest of your day out there. And what's all right at Colorado today?
It's actually pretty warm today, but we're supposed to get a bunch of snow tomorrow, so it'll be fun.
Okay, so that's why we need some moisture.
Yeah, exactly. So
that's it. Everything.
Yeah, exactly. Okay. Well, thank you, everyone. Have a good day.